Well, the James Webb Space Telescope has found an Earth-sized planet.
Since its launch in December 2021, the James Webb Space Telescope has been focused on reconstructing the universe's history by discovering unknown stars and planets. The James Webb Telescope has been quite successful in its mission of investigating the potential for life on new planets. Recently, the telescope discovered a potential habitable Earth-sized planet for the human race. How did James Webb come about the discovery of this Earth-like planet? What's so special about this planet that scientists believe could be the next Earth colony? Join us in this video to explore how the James Webb Space Telescope just discovered a habitable green music planet. The James Webb Space Telescope, JWST, is the most sophisticated telescope exploring our universe. It is equipped with high-resolution and highly sensitive instruments that help it to view objects too old, distant, or faint for the Hubble Space Telescope, its predecessor. The JWST uses infrared astronomy to conduct investigations across different fields of astronomy and cosmology. The telescope is tasked with the primary functions of observing the first stars and the formation of the first galaxies, and the detailed characterization of potentially habitable exoplanets. Working in line with this mission, the JWST has been pivotal in discovering a few habitable exoplanets. You will see this as we move further in this video. WASP 96 is one star that is the talk of the town in the scientific community. It is a yellow dwarf star that has excited space enthusiasts because it holds the possibility of being habitable by humans. It is similar to our Sun but differs by being cooler and older. This last bit of information came as a surprise to many scientists when they found out it is located about 1,150 light-years away from our planet in the southern constellation called Phoenix. The main sequence star is known for hosting at least one exoplanet. The most popular one is WASP 96b. We didn't know about this star until 2013 when it was discovered by the Wide-Angle Search for Planets, WASP. WASP is an international consortium of many academic organizations that have come together to perform an ultra-wide-angle search for exoplanets using transit photometry. WASP uses a collection of robotic telescopes to survey the length and breadth of the sky simultaneously. The telescopes monitor thousands of stars at an apparent visual magnitude from about 7 to 13. The program has two continuously operating robotic observatories that cover the northern and southern hemispheres. The first, SuperWASP North, can be found at Roque de los Muchachos Observatory on the island of La Palma in the Canaries. The other is WASP South, at the South African Astronomical Observatory in South Africa. WASP comprises the Isaac Newton Group, IAC, and 6 universities from the United Kingdom. WASP observatories employ high-tech instruments for follow-up characterization by using Doppler spectroscopy. WASP has been able to determine exoplanet masses. Each observatory of the program has an array of 8 Canon 200mm f1.8 lenses. WASP's telescopes are mounted on an equatorial telescope mount built by Optical Mechanic Incorporated. The Canon lenses come with a large field of view, giving each observatory a massive sky coverage of 490 degrees per pointing. The observatories operate by continuously monitoring the sky and taking images approximately once per minute. The observatories gather up to 100 gigabytes of data per night. These observatories use the transit method to measure the brightness of each star in each image. Furthermore, small dips in brightness caused by large planets passing in front of their parent stars can be searched for. One of the notable exoplanet candidates of WASP that has been identified as holding the possibility of being habitable is WASP 96b. The gas giant exoplanet has a mass of 0.48 times the mass of Jupiter. It is situated at 0.453 astronomical units away from its star WASP 96. From the data obtained from the WASP observatories, we know that this planet orbits its star every 3.4 days. It is about 1,120 light-years away from us. The scientific community learned of the existence of this planet in October 2013. The James Webb Space Telescope has studied the planet, and from what the JWST tells us, water can be found within this planet's atmosphere. It doesn't stop here. James Webb also discovered evidence of clouds and hazes in WASP 96b's atmosphere. This discovery came as a shock to NASA and the rest of the astronomical community because this planet was initially thought to be free of clouds. Guess we have to thank the high-precision cameras of the JWST for changing this narrative. The distance from which the WASP-96b orbits its star is just 1/10 of the distance between Mercury and the Sun. The discovery of water in WASP-96b means that exoplanet enthusiasts have been right all along. There is a possibility that we could have Earth 2.0 in one of these exoplanets. Beyond the excitement that comes with this discovery, scientists have been forced to ask an important question. How can water be found in a very hot planet like WASP-96b? To answer this question, we must go back to evaluate the history and chemistry of this amazing planet. WASP-96b belongs to a family of hot Jupiters, which are gas giants known to orbit very close to their stars. From what scientists have observed over the years, these planets are believed to have formed further outward in their planetary system. At this position, water seems to be abundant. Then the planets migrated inward due to gravitational interactions with other planets or their stars. The effect of migrating close to their stars is that they experienced intense heating and tidal forces that inflated their atmosphere and altered their chemical composition. The presence of water in the WASP-96b atmosphere has made scientists hypothesize that it retains some of its original icy material during its migration. Another notable member of the WASP family of exoplanets is WASP-76b, classified as a hot Jupiter planet. WASP-76b can be found in the constellation Pisces and orbits its host star WASP-76 within 1.8 days. The exoplanet is positioned at a distance of 0.033 astronomical units away from its star. WASP-76b is far bigger than our planet because its mass is about 0.92 times that of Jupiter. Although it is not an Earth-sized exoplanet, our descendants could one day live on this planet. Discovered on October 21, 2013, WASP-76b is the only known planet in its system and has an estimated equilibrium temperature of 2,190 Kelvin. Most of what we know about this planet was obtained from data collected by the Hubble and Spitzer space telescopes. From investigations, it was discovered that there is evidence of titanium oxide and a small amount of water in the planet's atmosphere. When astronomers used higher resolution spectra to observe the exoplanet, they found that ionized elements such as lithium, sodium, potassium, magnesium, calcium, manganese, and iron were present in its atmosphere. Further investigations revealed the presence of barium in 2022. In describing WASP-76b, scientists say it is cloudy, predominantly gray, and exhibits thermal incandescence. WASP is not the only successful space program that has helped uncover exoplanets. On our planet, the Transiting Exoplanet Survey Satellite, TESS, is another remarkable space program managed by NASA that has been pivotal in searching and studying previously known exoplanets. TESS is a space telescope that searches out exoplanets using the transit method in an area 400 times larger than that covered by the famous Kepler mission. Launched on April 18, 2018, TESS was designed to detect about 1,250 transiting exoplanets orbiting targeted stars. TESS was launched atop a Falcon 9 launch vehicle, and its first light image was taken on August 17, 2018. TESS makes use of an array of wide-field cameras to perform a survey of 85% of the sky. It is equipped with 4 wide-angle telescopes and associated charge-coupled devices, CCD detectors. The telescope operates by transmitting observed data to the Earth every 2 weeks. The development of TESS has made it possible for us to study the mass, size, density, and orbit of a large group of small planets. This also includes a small sample of rocky planets in the habitable zones of their host stars. Furthermore, we can say that TESS helps to make the work of the JWST easier because it provides prime targets for further characterization by the James Webb Telescope. Unlike the Kepler telescope and ground-based telescopes that have mainly detected large exoplanets, TESS has helped us uncover planets around distant stars that are too faint for characterization. As of November 2022, TESS had identified 5,969 candidate exoplanets, of which only 268 had been confirmed and 1,720 had been dismissed as false positives. LHS 475b is among the exclusive list of confirmed exoplanets. LHS 475b exists within the system of the red dwarf star LHS 475, situated 40.7 light-years away from the Solar System. LHS 475 can be found in the constellation of Octans. LHS 475's only known exoplanet was initially found in the transit data from TESS before the NPC instrument of the JEST confirmed it. One reason LHS 475b has held the attention of scientists is because it is close in size to the Earth at 99% of its diameter. However, a disparity occurs in temperature because it is much hotter than our planet. A visit to the exoplanet would find one experiencing an equilibrium temperature of 586 Kelvin. Scientists say that if we were to assume that this planet has little to no atmosphere, its day-side temperature would be estimated at 748 Kelvin. Unlike most confirmed exoplanets, LHS 475b has a very short orbit around its star. It completes an orbit within 2 days, and we suspect this planet is tidally locked. This means that only one side of the planet faces its star, basking in permanent daylight, while the other side is covered in pitch darkness. LHS 475b holds a special place in the history of the James Webb Space Telescope, JWST. This is because it is the first extrasolar planet to be confirmed by the JWST. More so regarding radius, it is very similar to Mother Earth. A look at the data obtained from the Webb telescope shows that LHS 475b is a rocky world. On the first look at this planet, scientists were astonished by its unique atmospheric spectrum. Another surprising thing about this exoplanet is that it lies closer to its star than any other planet in the solar system. LHS 475b was observed by JWST using 2 transits of the exoplanet. Each transit lasts 4.1 hours, providing James Webb 2.1 hours of observation. Thanks to NASA for creating the JWST because it is the only known telescope scalable for observing and characterizing the atmospheres of Earth-sized exoplanets. After studying LHS 475b's transmission spectrum, the Webb telescope found out the composition of the planet's atmosphere. Although the data is still being processed and the results are yet to be out, we now know what is not inside the planet from the data obtained so far. Scientists hypothesize that the atmosphere is filled purely with carbon dioxide. Thus, we need more precise measurements to differentiate a pure carbon dioxide atmosphere from a no carbon dioxide atmosphere. Furthermore, the Webb telescope has made us know that this planet is a few degrees warmer than our planet. This fact is proof that we should explore the planet better because it shows promise of being a habitable colony for the human race. If scientists were to discover clouds on this planet, then we would be forced to conclude that it is more like Venus, which had a carbon dioxide atmosphere. With more observation data expected to be presented in the coming days, we will finally be able to confirm some of these hypotheses. The first discovered Earth-size exoplanet reported by TESS is HD 749b. The discovery was announced on April 15, 2019. HD 749b orbits the orange main sequence star HD 21749. The star can be found in the constellation of Reticulum and has an apparent visual magnitude of 8.143. This can be interpreted to mean that the star is too dim to be seen with the naked eye. Credit should be given to TESS for letting us know that this star has 10 exoplanets. The first, HD 749b,